Hello and welcome back for lesson 6.3. We are going to work more on radicals today, and this time we're going to simplify radicals that don't actually work out perfectly. Okay, and so we can see if, like for instance, in number 1, if we put square root of 8 into Desmos, you will see. We're going to click on the square root and put 8 in there, but it doesn't come out to be a rational number. It's irrational. Just like if we put the square root of number 17, or I mean, number 9 is 48. That's not going to come out either. Okay. And if we go to our functions and all the way down the bottom and do the nth root, oops, to the nth root, and number 17 is the third root of 432, and that doesn't come out to be even root either. Okay, so we have to figure out how to simplify these as best we can. So what we're going to do is we're looking for a perfect root that is inside there. So this is a square root. So I'm going to look at this as the square root of 4 times the square root of 2, because 4 times 2 is 8. And I did that because I know the square root of 4 is equal to 2. So this simplifies to 2 times the square root of 2. Now the square root of 48, I'm looking for a perfect root that's inside there. So 4, we can factor 48 is 4 times 12. Because square root of 4 is a perfect square root. So we've got the square root of 4. 12 can actually be broken into another square root of 4 times the square root of 3. And so the square root of 4 is 2 times the square root of 4 is 2 times the square root of 3, which is, that is an irrational number. So this simplifies into 4 times the square root of 3. Takes a little guess and checking. You have to work in Desmos a little bit. So 288. I'm going to just look at my factors of 288 on my, so 288, I know that 4 is a perfect square root. So it goes into that. So square root of 4 is a factor. And then if we take 72 and divide that by 4 again, we get 18. So that's good. So there's another square root of 4. And then 18 divides by 9. 9 is a perfect square root. So I think that 4 times 4 times 9 times 2 is 288. So 4 times 4 times 9 times 2. Yep, it is. Okay. So 4, square root of 4 is 2. Square root of 4 is 2. Square root of 9 is 3. And then we have the square root of 2, which stays. So 2 times 2 is 4 times 3 is 12. So 12 times the square root of 2. Okay. So 13 and 17 are both cubed roots. So I'm looking for a number that has a perfect cubed root. So if you go back to page, it's actually in, I think it's in 6.1. We have some perfect cubed roots there on page 495. It would be maybe helpful to write them out just so you've got them by you. So we know that 8 is a perfect cubed root, 27, 64, 125 are perfect cube roots. So if we can use those as factors of a number, then that helps us along a little bit. So we said 27 was 1, right? So the cubed root of 27 times the cubed root of 2, because 27 times 2 is 54. And then if you go into decimals, or if you look on that page that we were just at, the cubed root of 27 is 3. And so you have a cubed root of 2 left over. Okay. So we can also go to our math and go to cubed root and put in 432, and we see that it's not. But let's look at some cubed roots. So 432, does that divide by 8? Well, it does. So that's one we can do. So the cubed root of 8. And then we have 54, and we already know that 54 from up here, right, separates into 27 and 2. So then we have the cubed root of 27 and the cubed root of 2. Because 8 times 27 times 2 is 432. And so the cubed root of 8 is 2. The cubed root of 27 is 3. And then we have the cubed root of 2 left over. So this is 6 times the cubed root of 2. These are crazy. So we're going to break apart 23 into the 4th root of 32, and then y to the 7 fourths. So we were working on this in the video in Zoom class today. So 7 fourths is 1 and 3 fourths. And then the 4th root of 32 is, we can look at 32 is 2 times 2 times 2 is 8 times 2 is 16 times 2 is 32. Okay, so we have one group of 4 2s. So 1 2 can come out, and then we're left with another 2 inside. And then we said our y to the 7 fourths is 1 and 3 fourths. So a y to the 1 can come out, and then we have 3 y's left, so y cubed. Tricky. Okay, so number 25, we're going to break this apart. So we've got the cubed root of 40. I'm going to write out my factors of 40. So 4 times 10. So the factors of 4 is 2 times 2. And then times 10 would be another 2 times 5. So we've got one group of 2s that come out. This would be a 2 out here. And it's still the cubed root, and 5 does not have anything to make a group, so it stays under. And then we have x to the 4 thirds. And that is 1 and 1/3. 1 and 1/3. So 1x comes out, and then 1x stays under. And then y to the 7 thirds. So 7 thirds is 7 divided by 3 is 2.33. So 2 1/3. 2 1/3. So y squared, that's what the 2 does. So y squared, and then 1y stays under. So let's make this a little bit bigger. So this is really 2xy squared, and then I'm going to move this over. So it's the cubed root of 5xy. Okay. So it's 31. I'm going to do the same. So I'm going to break down my factors of 64. It's the fifth root. I'm looking for groups of 5. So 64 is 8 times 8. And we already know that 8 is a perfect root. Well, it's 2 times 2 times 2. So we have 2 times 2 times 2 is 1 8. And then 2 times 2 times 2 is the other 8. And then we have x to the 8 over 5, which is 1. And then I have 3 remaining. And then y is to the 12 over 5. And so I have 2. 12 divided by 5 is 2. And 2 remaining. And we need a group of 5. So 1, 2, 3, 4, 5. So here's one group. And we have 1 left over. So 1, 2 can come out. We have x to the 1 y squared. And then the fifth root of 1 little 2 is left. And then x cubed and y squared. Whew. Those are tricky. Those are tricky. Tricky. Okay. 35 and 39 are asking us to do some substitutions, getting us ready for chapter 7. So it wants us to simplify. We're going to substitute in A, B, and C. So B squared. So we have to square all of the -6 minus 4 times A is 2 times C is 3. So this becomes -6 squared is 36. Subtracting 4 times 2 is 8 times 3 is 24. So this becomes the square root of 12. And we do need to simplify that as much as possible. The square root of 12 is, I'm looking for perfect squares in there. So the square root of 4 times the square root of 3, because the square root of 4 is 2. So 2 times the square root of 3. Okay. So let's do another one of those, except for now we're dealing with some fractions. Okay, so A is 1/2, B is a -1/2. So let's see, B, we have to square a -1/2 minus 4 times A is 1/2 times C, which is a -5/4. Okay. So a -1/2 squared is a +1/4. Subtracting. So this is a negative times a negative here on the -4 and the -5/4. So it's going to be a positive. So let's just change that now. And then 4 times 1/2 is 2 times a negative, times that now is a +5/4 because we multiplied that. So it's 1/4 plus 2 times 5/4 is plus 10/4. So this is the square root of 11/4. And we can separate those because we never want to have a square root in the denominator, and this one simplifies nicely. So this is a square root of 11/2. Okay. So 43, A, B, and C, they're asking us to simplify. So this is good. So we have to simplify any radicals that we can. So 10 plus this 75 is, we're looking for perfect square roots inside there. So square root of 25 times the square root of 2 over 5. And the square root of 25 is 5. So this is 10 plus 5 square root of 2 over 5. Now, we're going to be using this in chapter 7, so this is good that we're introducing this. So you can cancel out a 5 as long as a 5 can cancel out of all 3 parts. So it can, those cancel evenly in 10, 5 goes into 10 twice. So we have 2 plus, that 5 cancels completely and that completely, so 2 plus the square root of 2. So let's see here, on B, we have a negative 6 plus 45 could be the square root of 9 times the square root of 5 over 3. And I'm just going to separate these so you can see. So this is negative 6 over 3 plus the square root of 9 is a 3 times the square root of 5 over 3. So see, 3 can cancel into 6 twice, and the 3's here cancel out. So we have a negative 2 plus the square root of 5. Letter C. We're going to simplify this. We have a negative 2 subtracting, and then the square root of 27 is the square root of 9 times the square root of 3 over 6. So I'm going to separate these again. Negative 2 over 6 subtracting the square root of 3. The square root of 9 is 3, so that's going to be 3 times the square root of 3 over 6. So 2 cancels into 6 and leaves us with a 3. And the 3 cancels into 6 and leaves us with a 2. So we have a negative 1/3. Don't forget, when that cancels the numerator, there has to be a 1 there. So a negative 1/3 subtracting square root of 3 over 2. Okay, so now we're going to learn how to what's called rationalize the denominator. So rationalize the denominator, meaning when you have a radical or a root of some sort in the denominator, we need to rationalize it so there's not a root in the denominator. So it's an even root, square root or cube root. Okay, so that means I need to multiply by a perfect fraction that will get me to an even square root. So 6 times something. So you can always do the thing times itself if it's a square root. So if we do the square root of 6 over the square root of 6, that equals 1. We will then get 5 times the square root of 6 on top and the square root of 36 on bottom. And when you actually evaluate the square root of 36, you get 6. And that's what we want, is we don't want a square root in the denominator. So 5 times the square root of 6. And you can have a square root in the numerator. That's okay. Now, on number 51, we have to do the same thing. We need to get the square root of 5 to be just a 5 or some other number. So if we multiply by the square root of 5 over the square root of 5, we'll get the square root of 5 for the square root of 25. And then that simplifies to the square root of 5, and square root of 25 is just 5. Okay, so 55 is, we're ramping it up a little bit. So 55 now says we have a cubed root of 9. So I have to get to a perfect cubed root. And if we go back into 5.1, I'm sorry, 6.1. to that amazing page 498 where we did our perfect cube roots and square roots, and we had some fourth roots. So we can either use 8, 27, 64, 125. These are some common ones. And 9 can get to 27 by a 3. So if we multiply by the cubed root of 3 over the cubed root of 3, we end up with 2 times the cubed root of 3 over the cubed root of 27. And the cubed root of 27 is just 3. And that's what we want, is we want that to simplify to an integer. And then you have 2 times the cubed root of 3 in the numerator. And now number 59 is, we have to rationalize again. We have the fourth root. So the fourth root of 8 over the fourth root of y. So we have to multiply by something, another fourth root. So we have 1y, we need 4 of them because that's what the 4 means. So we're going to do y cubed. Y cubed. So in the numerator, we're going to have the fourth root of 8y cubed, and that's fine that that doesn't simplify because that's not a necessity in the numerator. And that's so we can see that that's a 3. Okay, and now we have the fourth root of y to the fourth, which is y to the 4 over 4. So that equals just y. That's what we wanted. So we have the fourth root of 8y cubed over y. Woo. Few more. So 63. It says rationalize the denominator still. I don't know why I didn't write that down. It's the cubed root of 2x over 9y. Okay, cube root of 2x over 9y. Okay. So we already know that the cubed root, if we can get 9 to 27, 27 is a perfect cubed root. So we can multiply by 3 to get to 27. And then we need y cubed, and we just have a y, so we can multiply by y squared. So then we're going to do the identical on top. And this is a cubed root. It has to be the same root for this to work. So now in the numerator, we've got 2 times 3. So it's the cubed root still of 6xy squared over the cubed root of 27y cubed. And so my denominator simplifies to 3y, which is what we wanted. And then the numerator is just the cubed root of 6xy squared. Okay, 67, one more. So 67 is dividing, and before I start worrying about rationalizing this, I notice that 75 divided by 2 is 50. And then I wouldn't have a 2 in the denominator. So that would make things a little bit easier. And then I still have the square root of z in the denominator. So I still have to multiply by something to rationalize that. Okay. So I'm going to multiply by, it's a square root, so I just need another z. So I can multiply by z over z. So this is going to be the square root of 50 x cubed y squared z over the square root of z squared. And I'm going to simplify everything in the numerator that I can. 50 can break apart into a perfect square root of 25 times 2. So this could be the square root of 25 times the square root of 2. And then that could be x to the 3/2. So we can simplify that into 1 and 1/2. And then y to the 2 over 2. That's cool. That simplifies to 1. And then z to the 1/2. That's not going to go anywhere. And then the denominator is the square root of z squared. So that's just z. Okay. So I think my final simplification here is the square root of 25 is 5. I'm going to cross them off after I've simplified. So that's done. The square root of 2 is going to have to stay under the square root. So I'm going to start that over here. X is to the 1 and 1/2. So x to the 1 comes out. And then the remainder of 1, that x stays underneath. And then z, oh wait, we've got y to the 1. And then z didn't have a pair, so this has to stay under. This is a square root all over z. So just assume that we want you to rationalize so that you don't have square roots in the denominator. And then the last problem says, simplify each expression. Do not assume the variables represent positive numbers. So 25x squared is going to simplify the square root of 25, square root of x squared. And that's just 5. And x to the 2 over 2, which is 1. So this should be 5x. And we have to make sure that we're talking about the absolute value of x. It can't be, it would have to come out to be a positive. Because of a number multiplied by itself always results in a positive. So fun. So there is a short assignment for 6.3 out of the book to give you some practice, and catch me back for our last chapter, chapter 7.